I'm already subscribed. And by the way, if you're watching this and can subscribe too, I'd really appreciate it. It helps us a lot. I've been waiting to appear in your videos, and here I am. I have a question. If my house starts to catch fire, and I get in the shower and turn it on, will I survive? This is one of those questions that seems silly, because everyone is thinking, oh, of course I know this, but you don't really know the exact answer, which is very important and could save our lives. So stay until the end, because I'll answer this one at the end, okay? I won't say it's a silly question, because I already know the answer. That's right. I believe there are no silly questions, and I'm sure yours isn't silly either. How do TV satellites work? Because I know that the antenna at our house has to be pointed at a specific place. But doesn't the satellite keep orbiting around the Earth? That's right, this question isn't silly here or in China, where the satellite will pass by in 15 minutes. Most of the satellites we launch orbit the Earth very quickly. The people on the International Space Station can see the sunset several times in a 24-hour period up in space because they're orbiting much faster than the Earth's rotation. The thing is, if you put a satellite a little farther away, it can orbit a bit more slowly. If you keep putting it farther away, it can orbit even more slowly until it reaches the point where the satellite orbits at exactly the same speed as the Earth's rotation. And then you can, for example, have a satellite that's looking at the planet, at Brazil, the whole time. It's locked, rotating together with the Earth, always looking at Brazil. That distance is pretty long, okay? It's called a geostationary satellite. Let me check the exact distance for you. It's 36,000 kilometers from the equator. Just so you have an idea, the International Space Station is about 400 kilometers away. It's much farther than the nearby satellites we have here. And if you have the thing fixed up there in the sky, you can have an antenna aimed exactly at that satellite. Carlos Silva, channel member, look, your question is guaranteed to be answered, huh? There's always at least one question from the members here on Iberê Respond. When you guys record Bora V, do the factory people take the chance to gush over you? I always get the impression there's a wall of people watching you record. People always take pictures. Depending on the factory we go to, there's a certain age profile and everything. A lot of people know Manuel do Mundo. When we filmed the tire video, someone emotionally told us they chose a technical career and work at the factory because of Manuel do Mundo. That made me very happy. And sometimes a lot of people come to watch the recording, so we don't say anything wrong or show something we shouldn't. Most factories have some kind of trade secret. What is a trade secret? Some machine, some way of doing things, some robot, some ingredient that they don't want competing companies to find out about because it improves their production in some way, makes it cheaper to produce, and so on, and they don't want that to show up in the video. So, it's normal to have at least 10 or so people behind the camera. In the beginning, that made me really embarrassed. Now, I'm used to it. What is the biggest difficulty in going to Mars? Once again, the answer seems obvious. It's obvious, but it's not obvious. Here's the thing. The moon is the farthest place humans have ever been. 384,000 kilometers is the distance from Earth to the moon. Do you know how far it is to Mars? There isn't an exact distance to Mars. It's kind of complicated. Here is the sun. This is Earth. This dotted line shows Earth's orbit around the sun. And here is Mars with its own dotted orbital path.
Esse pontilhadinho é a órbita de Marte.
And you can imagine, looking at this drawing, that the distance between Earth and Mars is this one here, right? If it were this distance, it would be about 54 million kilometers. But you probably imagine that Earth and Mars don't go around the sun together. Earth moves much faster than Mars, so there can be a situation there. Mars is exactly on the far side of the sun from Earth, much farther away than the sun, and in that case, the distance is about 400 million kilometers. That's why you can't say there's a fixed distance between the two planets, because these distances keep changing, and what's more, those orbits, they're not perfect circles either. They're not perfect circles like those drawn with a compass. They resemble eggs, making calculations more complex. From the moment Earth is as close as possible to Mars until the two planets meet again, it takes about 2 years and 2 months, and that to Mars is 140 times the distance from Earth to the moon. That's really far. When Mars is on the opposite side, it's roughly 1,000 times farther from Earth than the moon. And what's more, at this distance, light takes about 22 minutes to travel from Earth to Mars. That means, imagine someone having a terrible stomachache there, and then they call Earth and say, guys, I don't know if it's appendicitis, if it's a kidney stone, help, what medicine should I take? That message takes 22 minutes to reach Earth. The doctor here replies, and the message comes back. And then the doctor here
Responde e a mensagem volta. No total, ela esperou 44 minutos.
from the time of the question to the answer. Now, imagine this person wants to return to Earth. I don't want that. It's been 3 days, and I already want to go back. The chance for the two planets to get close has passed. He said, there, and 2 years too, because she'll have the opportunity to come back. People are really enjoying astronomy here, huh? Are all the bright spots in the sky at night stars like the sun, or is there something else? I swear to you, I get emotional when I see these questions. It's not even close to being an obvious question. It's a hard question to answer. And the answer is incredibly cool. To start with, yes, the vast majority of stars you see up there are, in some way, similar to the sun. There are much bigger stars, there are smaller stars. Sometimes you see a star that you think is just one, but it's actually two or more that are really close together. But the vast majority are stars, regular stars, but we can see at least 5 planets with the naked eye here from Earth. These planets, when you look without a telescope or anything, without really observing the sky, they look like stars. You'll think they're stars, so look: Mercury, Venus, Mars, Jupiter, and Saturn are visible from Earth, but you can also see galaxies. You can see the small and large Magellanic Clouds and Andromeda. And there are also comets. If a comet is passing by, you'll see a little dot moving across the sky. If you're really lucky, maybe it'll be more than just a dot. But anyway, it's up there in the sky. But there are also nebulae, which are clouds of gas and dust. You can see the Orion Nebula from Earth with the naked eye. And you can't forget about shooting stars. They're meteors falling from the sky, streaking across the sky, right? That fireball we see falling, which we even call a shooting star. But that's not all. There are also artificial satellites. The International Space Station, for example, if it's in a position where it reflects sunlight, you can see a bright object passing by in the sky. I highly recommend that little app we showed in that video, 5 augmented reality apps called Skyview. And in this app, you can type in International Space Station, and then you point your phone to where the International Space Station is. It tells you it's right there, or it'll say it's down there, on the other side of the world, and it'll pass overhead on such and such day and time. Anyway, you can see all of this that I mentioned. It's really cool. If car in English is car and man is man, then a person named Carman is a train transformer. Is my question for the live stream already guaranteed? If not, why don't clouds full of water fall? This question came up during the last live stream we did. We played live Truco here with the people from Manuel do Mundo, and we didn't know how to answer. And the answer is simple. It does fall, in the form of rain. Next question. Hey, this is Manuel do Mundo, and we like to give proper answers. So I did a lot of research about this phenomenon, and it's much more complicated, but also much cooler than I imagined. To start with, let's understand why a drop of water, if it's really tiny, really tiny, it's very hard for it to fall. Here, I have 100 milliliters of water. If I throw this water, it plummets. It falls as if it were a stone, right? Normal. But what if I broke this water up into really tiny droplets? It falls much more slowly. It takes a few seconds to reach the ground. But these spray drops are much larger than the micro droplets in the cloud. Up there, they would take much longer to fall. But why does this happen? Doesn't gravity pull water the same way? Does it have the same density as the water we have down here? What's the difference? When we start dividing any object, its area, its surface gets bigger and bigger. Take this piece of styrofoam, for example. Its surface is this outer area. Okay, it's like we have a shell around it. If I cut the styrofoam, we have the same surface we had before, but I gained this one here. See, there's more surface. If I cut it one more time, we gain this one here. See, every time I divide it, I get more surface area, but the weight of this stays the same. So if we keep cutting this piece of styrofoam into smaller and smaller pieces, it keeps gaining more and more area, more and more surface. And objects that have a lot of surface area experience a lot of air resistance. When they fall, they move through a lot of air. A feather, for example, is super light, but it has a huge surface area. When you throw it, it has trouble falling. The same thing happens with a parachute, and that's why microscopic droplets of air will fall very slowly. Actually, they hardly fall at all. It's much easier for them to rise. Look, let's imagine the sea, for example. The water on its surface will start to evaporate. And here we'll have water in its gaseous state, okay? This is still water vapor. I noticed something interesting I hadn't realized before. Air is mainly made up of nitrogen and oxygen, but the molecules of this nitrogen gas have two nitrogen atoms, and the oxygen ones have two oxygen atoms. So we'll have a net and while water is aqueous, there's a detail here, which is that hydrogen is extremely light, while oxygen and nitrogen are somewhere in the middle. In practice, what does that mean? It means that the water molecule is much lighter than the oxygen and nitrogen molecules. So what happens is that when we have water molecules mixed in the air, these molecules tend to rise, and the air will rise along with them. It's like when we have a helium balloon. It's much less dense than air, and it goes up. What will happen here at sea is that this will start to rise. We're going to have air rising because water is light. Always remember that it's still in the gaseous state, okay? But there will come a time when all this humid air that's rising will meet a colder layer. And then, you know what's going to happen? The same thing that happens to your cold soda bottle. It will start to condense, LD, forming tiny droplets of liquid water, or sometimes even ice. These tiny droplets here are what make up the cloud. In fact, that's why the base of clouds is usually flat, because that's where the humid air meets colder air. But there's another phenomenon happening here that's really cool. When water condenses, when it goes from vapor to liquid, it releases heat. So here it's going to get a little warmer around these droplets. And the tendency is that they'll rise even more. So you notice that we basically have two driving forces that make these droplets rise. First, the air that's coming from the bottom up, because water is lighter than air. And then we still have condensation that warms the air a little and makes it rise again. And it's because of all this that the cloud stays up there, even though it's liquid water. Of course, sometimes there will come a moment when you have so many droplets here that they start to come together. And if they start to come together, it's kind of like if we took that piece of styrofoam and started gluing the parts back together. There will come a time when the surface area around it gets smaller and the mass gets big. Then the rain falls. One important thing for me to say is that I posted this question on Twitter. A lot of people helped me, send me several texts, several videos. But there was one person in particular, Marina. Her handle is down here, who gave the complete answer with all the details. It was really cool. So, thank you, Marina. All the water from the rivers goes to the sea, and the sea doesn't rise. For what reason? For the reason we just saw, the sea water evaporates, and that's why it doesn't rise. But wait, there's something interesting in this story you may not have considered. Not every river goes to the sea. Imagine the rivers that flow into the Dead Sea, for example. That sea doesn't go anywhere, it just evaporates, it disappears right there. We call this group of rivers that flow into a lake that doesn't reach the sea an Endorheic basin. It's not such a rare thing, okay? For example, the Caspian Sea is one of those seas that doesn't empty into any sea. All rivers flowing into the Caspian Sea, which is very large, don't reach the ocean. I mean, the Caspian Sea is called a sea, but not in the sense of a sea like we were thinking, as in an ocean. Cool. Right? If I buy a car, get it insured by 4 different companies, and it gets totaled, can I get 4 new cars? I read a lot about this. You can even have 2 insurance policies on the same car, but you have to let the insurance companies know you're doing that. When the car is totaled, they'll pay you, at most, the full value of the car between the two. Okay, I don't know, it'll be half from each one, or they'll have to work something out to pay you, at most, the value of the car you lost. But you can get insurance for 2 different things on the car with different insurance companies. For example, you get insurance against theft and collision in one place, you get third-party insurance in another, and there's no problem at all. The thing is, it ends up being more expensive. It's cheaper if you buy the whole package in one place. But there's something interesting I found out. Life insurance, you can get it from several different insurance companies, and all of them will pay you. I mean, yeah, they'll pay the people who survive in this case. And this happens because a car has a fixed value. We know the value of the car. It's right there in the FIP price guide, the value of the car, right? Life isn't like that. So you can have life insurance for whatever amount you want. So there's no problem. You can insure 10,000, 10,000, 10,000, and 10,000, or 40,000. Anyway, that's fine. I is asking, why can't we turn fire upside down? First, let's do a test here, okay? Can we really not do it? I light the fire. I mean, I try to light the fire. It catches fire, and it's facing upwards, see? upwards. No matter how much I turn the matchstick upside down, the fire keeps pointing upwards. The fire is a visual sign of a chemical reaction that's releasing heat. So, there we have the fuel reacting with the oxygen and giving off light. And if it's a reaction that's releasing heat, that means the gas is there. The carbon dioxide, the water that's coming out, they're really hot. They're going to rise. So we're going to have a cycle. Some gases rise to take the place of those that went up, and air with oxygen comes in to feed the fire. So there's gas rising and new gas coming in. There's no way we can change that. If you turn the stick upside down, what's being heated will rise the same way. So does that mean that in zero gravity, we'll have a different kind of fire? Yes. Fire in zero gravity is really weird because we don't have that cycle anymore. The moment those gases heat up, they won't rise. They'll stay around the flame. And then fresh air doesn't come in, so the flame becomes kind of weak. In a spherical shape, something really strange, like what you're seeing here. When is the big biology book from Manual do Mundo coming out? For biology, I don't have an exact date to tell you, but the chemistry one will be out soon. I think that by around July, we'll release the big chemistry book from Manual do Mundo. And that's really cool because chemistry has always been one of the strongest things we've had here. We do far fewer chemistry experiments now, but do you remember the Super Química days? There was at least one giant chemistry experiment every month. We don't do as many chemistry experiments anymore because we've already done a lot and we've run out of experiments that are easy or less dangerous to do at home. Why do animals have scientific names? That's a really good one. It's not just animals, okay? All living beings, plants, fungi, we all have scientific names. Let me give you a clear example here. Let's take this creature that's on the screen right now. I've always called this animal a cougar, but in many places, it's called a puma. The indigenous people of Brazil, a chemical part. We want to do a chemistry experiment. So we have to experiment with mountains. Now, imagine two scientists talking, right? From Argentina, from Brazil, and from the United States. One says cougar, another says suarana. No, mountain lion, it becomes a mess. Nobody knows which animal you're talking about. So every living being needs to have a unique name. That's what we call the scientific name. The name you use for this animal, anywhere in the world, it will always be called that way. Usually, this scientific name is based on Latin. So, the name of this animal I just showed is puma in color. It works like the ID card of this puma. When you write these names, we usually write them in italics, okay? If you're on the computer, the first letter of the first word is capitalized. This first word is the genus. Genus is the group that is below family in the classification of animals. So we are from the genus Homo. The puma is from the genus Puma. And there's another little animal that's also from the genus Puma. It's really cute. It's like a cat, really funny. And the second word is the epithet, which defines the species of the animal. So several animals will start the same way, right? The first word will be the same. And then we have a specific word. And that's how the scientific name is formed. First, why isn't the collective noun for capybaras capybaras? Look, I was just going to read this question and laugh, but then it hit me that I don't know the collective noun for capybara. What is the collective noun for capybara? For example, a group of wolves is called a pack, right? Horses, you can call a troop, right? So when we see that group of capybaras here on marginal Pineiros, what is it called? It's a herd.
But in Bearman there were no elephants nor capybaras. Capybaras are big, but they're not as big as elephants.
Oh man, you learn one thing and then you get stuck on it. A herd can be of several different animals. For what I researched here, look, herd can refer to capybaras, elephants, oxen, donkeys, horses, or buffalo. And there must be some other animal that I missed, just like there must be something else we see in the sky that's not a star that I probably didn't mention. Man, there are so many questions. What will happen when the CPF numbers run out? Will they use the numbers from people who have died, or will they add another digit at the end to the number? Has this ever happened before? Yes, it has happened before, but as far as I know, not with CPF. Let's understand the CPF number first. This number isn't just any simple number. It has some secrets. The last two digits are called check digits, right? So what happens? The computer takes those 9 digits before and does a calculation. The result of that calculation has to match those last 2 digits at the end. That's why when you enter the wrong CPF, the computer immediately notices because the check digit doesn't match the CPF you entered. It's a way to check if the CPF is correct or not without having a database with that person's information. You don't know whose CPF it is, but you know it's not correct. Except for those 2 digits, the last number of the CPF indicates the region where the CPF was issued. And then, yes, the other numbers are free to vary. So that means we have 9 digits to create a CPF. Considering that this region digit will vary, right? We can count that digit as well. That gives a billion possibilities for the Brazilian population to reach that number. I don't know if we'll ever reach that. Just so you have an idea, Brazil today has 214 million people. But then something very interesting comes into play. People pass away, but the CPF number remains for that person who died. So it's not about how many people we have today, but how many people we've had since this number was created. And then this number will run out. Even if we don't reach 1 billion inhabitants, we'll reach 1 billion people who have had a CPF at some point in their lives. And what do people usually do when that happens? It's what you mentioned. We add numbers not at the end, but usually at the beginning. And that's what happened with phone numbers throughout history. Look at this old ad here on the side. Look at the size of the phone number. It's really small. Nowadays, cell phones have 9 digits. When I was a kid, phone numbers had 6 digits. And I remember the phone number kept getting longer. Nowadays, in Paydagio, landline phone numbers have 8 digits. And they kept adding digits at the beginning. The same thing happened with license plates, okay? When I was a kid, it was 2 letters and 4 numbers. Today, there are already 7 characters with letters and numbers, and that gives an absurd amount of possibilities, because in each position, you can use any of 10 digits or 26 letters. I wanted Iberê to explain how it works. Carrier pigeon. It has nothing to do with a pigeon carrying a letter and knowing addresses. One very important thing is that we shouldn't say something doesn't make sense before we understand how it works. And if you're saying you want to know how it works, then it does make sense. It's like, let's understand how this thing works, right? That's not how carrier pigeons work. I don't write the address on its leg, so it doesn't know to deliver the letter to Iberê's father at the toll booth. The carrier pigeon only knows how to go back home. So, what would work is, I take the carrier pigeon in my car, then I go, I don't know, to Santo André, here near Sao Paulo. If I need to send a message to Mari, I put the message on the pigeon's leg, attach it, release the pigeon, and it goes back to my house. It always knows how to return. It doesn't know how to go to an address that's different from its own home. And there are some interesting things. For example, a pigeon flies about 30 to 50 kilometers at most. They are trained to fly long distances. So the carrier pigeon, the one that actually works as a carrier pigeon, isn't just any pigeon you pick up off the street and make it work. But there are carrier pigeon competitions to see which one goes the farthest. And in those cases, there are places where the carrier pigeon travels more than 1,000 kilometers to get home. What are you most proud of, and what makes you happy? Maybe a lot of people would think I'd say Manuel do Mundo. Yeah, until a few years ago, that's what I would have said. Maybe Manuel do Mundo. Or saying that being with Mari is what makes me happiest. But after you have kids, yeah, that surpasses anything that's ever happened to you in life. So what I'm most proud of is seeing the girls learning things, them telling me about their stuff, us having these conversations. And the things that make me happiest are spending time with the family, being with her, with Helena, with Mari, with Melissa, traveling together, laughing together, and everything else. There's nothing better than that. But let's get to the question that opened this video. And maybe you clicked just to find out the answer. After all, I chose a question to be the title of the video. If the house is on fire and you get under the shower, will it help at all? Probably not. And it's not because being wet doesn't protect you much from the fire. It's worse than that. If you get wet, maybe it will be harder for a flame to hurt you. But the vast majority of people who die in a fire, they die from suffocation. Because they breathed in toxic smoke that was coming out, or because there was no more oxygen left to breathe. So unless the fact that you're locked inside the bathroom would isolate you from the rest of the house and keep the smoke from coming in, but then the fire wouldn't get in either. It wouldn't really help much for you to get in the shower. The thing you need to do is crouch down and stay close to the floor, because hot air rises. If hot air rises, the toxic smoke will also stay at the top. And what's more, the hot part, the part that can burn you, will be up above. When we did Bora V at the fire department, I went into a container that was on fire. There were a lot of flames inside, and we had to put out the fire. I couldn't stand up at all. If I stood up, I would die because the temperature up there was very hot and down below it was much cooler. But to sum up, what can really save your life is to get down during a fire and find a way to get out of there without breathing in the toxic smoke. Honestly, I really want to make a series about what we should do in these emergency situations. But a real series, you know. What should you actually do if your house catches fire instead of hearing a bunch of guesses? Maybe talk to a firefighter and all that. Yeah, tell us in the comments if you think this series is cool, if you would watch this kind of video. It's unlikely that we could actually recreate these situations. Okay? For example, if a car falls into the water and I'm inside the car, what should I do? We can't just throw a car into the water and all, but I think it would be worth knowing what to do in those situations. What do you guys think? Guys, remember to give us a thumbs up. Big hug to everyone. Was I mentioning the fire department? No, there was a really cool video we recorded with them showing why you can't throw water on a pan of oil that's on fire. You should check out this video, because it kind of follows the idea we had for this series I mentioned to you. So, if you like this video, maybe it's worth recording more.